Hi everyone, it's Mrs. Bebo. In this video, we're going to talk about subtracting linear expressions. So our main goal for this video, how do I subtract linear expressions? So to start, we're just going to review some important vocabulary, which is linear expression. A linear expression is an algebraic expression in which each term is a constant or the product of a constant and the variable raised to the first power. Note, when simplified, a linear expression cannot contain a variable in the denominator of a fraction. So just as a reminder of some of our examples, our linear expressions could be something like 5x, so it's a singular term. It could be multiple terms, right? But again, the biggest thing is that the variable is raised to the first power. Some examples of nonlinear expressions, we have two variables, right? We have a variable that's to a power other than 1, or we have, again, that variable in the denominator, which again actually just means this is the same as 6 times x to the negative 1, something you learn about later in Algebra 1. So we're looking at linear expressions where all of our variables are to the first power. So one of the things that we want to keep in mind is working with the additive inverse of expressions, which the additive inverse basically just means we're going to rewrite these linear expressions as the opposite. And we're going to use that knowledge when we go through to subtract these linear expressions. So the opposite of 5x minus 7 would be a negative 5x plus 7, right? So that 5x was a positive in our original expression. Now it's a negative. Instead of subtracting, the opposite is to add 7. So let's try the second one. So negative 7x plus 3, the additive inverse of negative 7x plus 3 would be a positive 7x minus 3. Again, the opposite. All right, how about the third one? 4x plus 5. Again, the opposite of 4x plus 5 would be a negative 4x minus 5, because again, we're just taking those original terms and making them the opposite. So instead of being positive 4x, it's a negative 4x. Instead of being plus 5, the opposite is to subtract 5. So number 4, we got negative x minus 10. The opposite of this, the additive inverse of that linear expression, would be x plus 10. So additive inverse, we're going to use this knowledge to help us subtract linear expressions, because when we subtract linear expressions, we're actually going to do what we did with integer operations. Keep, change, change. We keep the first linear expression the same. We change that subtraction side, the center of these two expressions, to the opposite, right, to addition. And then we're going to change the 3x minus 2 to the opposite linear expression, because one of the rules that we talked about when we subtract integers is that you add the additive inverse, right? Keep, change, change is a really simple way of remembering how to work with subtracting integers and subtracting linear expressions. So what does that look like? Well, for this first one, we're going to keep the 6x plus 5. We're going to change the subtraction to addition. And then we're going to change that 3x minus 2 to its opposite. So we just practiced that on the last example. So the opposite of positive 3x minus 2 would be a negative 3x plus 2. And then at this point, it's just working with combining like terms. We could go through and line these up vertically. You could also keep it horizontal. I just like to ignore my parentheses at this point and then worry about combining like terms. But again, it's whatever strategy works best for you. I notice that I have a 6x and a negative 3x. And then I also have a 5 and a 2 as like terms. So the 6x plus the negative 3x is going to be a positive 3x. And then this 5 plus 2 would be a positive 7. So we're going to write plus 7. And then that's my final answer for that subtraction question. So 6x plus 5 minus the quantity of 3x minus 2 is equal to 3x plus 7. So let's try the second one on this slide. It says find negative 4x minus 7 minus this quantity, this linear expression, negative 5x minus 2. Again, our trick is to keep, change, change. We're going to keep the negative 4x minus 7. We're going to change the subtraction to addition, and then the negative 5x minus 2, we're going to change that to the opposite, a positive 5x and then plus 2. So instead of subtracting 2, plus 2. Then at this point, again, if you want to line them up vertically, if that helps you to add these, right, go for it. Otherwise, I'm just going to ignore these parentheses. And then I'm going to combine like terms. One of the steps I am going to take though first, I notice that I'm subtracting 7, so I'm going to write that as plus -7 so that I don't lose track of the fact that that is actually a -7. And then I'm looking for my like terms. I have a -4x, and then we have this positive 5x. Then we have our -7 and our 2, so those are our constant terms. Again, those are like terms. So -4x plus 5x is going to be 1x, or just x. -7 plus 2 is going to be a -5. So if I write it out as this first, so x plus -5, remember that's technically not simplified, so we're going to write it as x minus 5, and then there's my final answer for that question. All right, taking a look at some more examples here. So these ones involve fractions, but we're still going to do the same idea with the keep, change, change. So that's why I have KCC written underneath both of these problems to help us remember, yep, that's how we subtract linear expressions. Keep the first expression the same. So we're going to write 2/3 x plus 1/2. We're going to change the subtraction to addition. Then we're going to change that second linear expression to its opposite. So this is going to become -1/6 x plus 3/8. Then at this point, I'm going to ignore those parentheses. That's just what I like to do. Again, that's not the only strategy to adding linear expressions or simplifying expressions, because it's essentially the same thing here. Whatever works best for you. This is just what I think is easiest in my opinion, but you do you. So 2/3 x plus this -1/6 x, those are going to be like terms. So I'm actually going to go ahead and just rewrite these next to each other. So I'm using my commutative property to rearrange this expression here. And then that 1/2 and 3/8 are also like terms. Now 1/2, that is the same as 4/8. So if I rewrite this as 4/8, just so that we have a common denominator, because we're going to need one. Those are going to be my constant terms that are like terms. Then for the 2/3, again, between the 2/3 and the 1/6, a great common denominator would be to use a common denominator of 6. So we're going to multiply the 2 and the 3 both by 2 to change this to 4/6. And then we're going to be able to go ahead and combine those two. So the 4/6x plus the -1/6x is going to make 3/6 x. We have the 4/8 plus the 3/8, so that's going to make 7/8. And then we do need to make sure we simplify our fractions. So with the 3/6 x, we do want to simplify that to a 1/2 x. And then we have this plus 7/8 still on the end. And then that's my final answer for that question. So now for this next one, again, involving fractions, we have 3/5 x minus 1/8 minus this 1/3 x minus 3/4. Again, keep, change, change. So we're going to keep the 3/5 x minus 1/8 exactly the same. We're going to change the subtraction to addition, and then we're going to change this second expression into its opposite. So -1/3 x and then plus 3/4. And then what I like to do, I like to drop the parentheses, so I'm just going to ignore those. And then I am going to notice that I do have this subtracting 1/8, so I'll rewrite that as adding a -1/8. And then I'm just going to rearrange this so again that my like terms are right next to each other. So we have the 3/5 x plus this -1/3 x. Then we have our -1/8, so plus -1/8 plus 3/4. So that way it's just nicer to see what we're working with. And again, we can clearly see, yep, here's my two like terms. And then we also have our variables as like terms as well. So for the 3/5 x and the -1/3 x, we're going to want to use a common denominator of 15. So showing what this turns into, again, you're going to multiply the 3 and 5 both by 3. So this turns into 9/15 x. And then for the -1/3 x, again, you're going to multiply both the top and bottom by 5. And so this will turn into 5/15 x, -5/15 x. Don't want to forget that negative's there. Then for the -1/8 and the 3/4, again, we are going to use a common denominator of 8. And so for the 3/4, that is the same as 6/8. All right, and then combining our like terms, 9/15 x plus a -5/15 x is going to be 4/15 x. Plus the -1/8 plus the 6/8 will be 5/8. And then none of those fractions can be simplified, so this is my final answer. All right, so moving into our next example, we have a story problem. This one says that Bonnie owns a t-shirt shop where she sells plain t-shirts and printed t-shirts. The table shows the cost per shirt and the number of each type of shirt sold over W weeks. After 25 weeks, how much more did she earn in sales of printed t-shirts than in sales of plain t-shirts? So right now we have our plain and our printed. It says the cost for each of them are $15. The number sold was 5W minus 4 and then 8W plus 3. So on that table, we can see that the cost for each is exactly the same. So really what we need to worry about is the difference, because when it says how much more does she earn in sales of printed t-shirts, that means she's made more money based on those printed t-shirts, which again, we just got to find that difference. How many more were sold over the course of 25 weeks? So our first step is to find the difference in these two expressions. And yes, again, there are multiple ways that you can solve this question, but again, the whole purpose of this video is to work with subtracting linear expressions. So that's what we're going to do here. So step one is to subtract those two linear expressions. It does say that we earned more just with the way the question's worded. How much more did she earn in sales of printed t-shirts? That is the greater amount. So the 8W plus 3 is going to be written first. And then we're taking away the plain shirts, which were the 5W minus 4. All right, so now we're going to keep, change. So keep the 8W plus 3 the same. We're going to change the subtraction to addition, and then the 5W minus 4 we're going to write as the opposite, so negative 5W plus 4. Ignoring the parentheses, we're going to combine like terms. 8W plus negative 5W would be 3W, and then 3 plus 4 is going to be 7. So that just is my simplified expression. That is the difference, right, between the printed and the plain. So now for step 2, we can actually plug in W. So they tell us after 25 weeks, so that's what W is. So W is going to equal 25. Now we can solve this expression for that value. So 3 times 25 is going to be 75 plus 7. So 75 plus 7 is going to end up being 82. Or 82 shirts was the difference between, again, the printed and the plain. So for step 3, now we're going to figure out that cost. So how much more did we actually make because of that difference? Well, again, the cost for each was just $15. So we're just going to write $15 times the 82 shirt difference. Multiplying this out, we write our work off to the side here. We get a final answer of $1,230. All right, so one last story problem, and then that's going to be it for this video. So this one says the table shows the sale of college and professional team hats at a shop for M months. After 10 months, how much more will the shop have made in sales of college team hats than the sales of professional team hats? So again, with this, we're going to set it up the same way we did on the previous question. I understand that there are other ways that you can solve this, right? We could plug in M, where 10 is M. We could do that right away and then find that difference. I'm going to go through and do it just like the way we did before, though, with, again, giving us a chance to practice subtracting linear expressions. So the way that this question's worded, how much more will the shop have made in the sale of college team hats than the sale of professional team hats, tells us that the college team's hats are the greater amount. So we're going to have the college team, so 6M plus 3. We're going to find the difference, again, how much more, and then we're subtracting the 5M minus 2. We're going to keep, change, so keep the 6M plus 3. We're going to change the subtraction to addition. The 5M minus 2 we're going to rewrite as the opposite. So negative 5M, and then the subtracting 2 is going to become an adding 2. Combining like terms, the 6M and then negative 5M is going to make 1M, plus the 3 plus 2 is 5. So that's our simplified expression after finding the difference between those two. And then now we can actually evaluate that expression where M is equal to 10, because again, they tell us that in the question. So now we're going to have 10 plus 5, which tells us 15. So 15 hats is the difference between the college team and the professional team. Now they say, again, it's $21. So step 3, you're going to take the number of hats that were the difference between the two types. So we're going to do 21 times 15. Again, we can write our work off to the side here. We get an answer of $315. All right, well, that's it for this video. So thank you again for watching, and I hope this helps you with subtracting linear expressions.